In this session, we are going to discuss about the relationships among the forward difference operator, backward difference operator, and the displacement or shift operator E. Now, we know that backward difference operator, when it acts on a function f of x, we get f of x minus f of x minus 1, minus h. That simply means that where you are standing, you go one step backwards. So that if you were to draw some sketch here, so if we call this one x, and then this x plus h, this x plus 2h, x plus 3h, x plus 4h, and then this would be x minus h, x minus 2h, x minus 3h, x minus 4h. So the spacing is h, 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 h. So the value of the function usually at this point be f of x, and then f of x minus h, f of x minus 2h, etc. This would be f of x plus h, f of x plus h, 2h, etc. So if you want to define the backward of f of x, so at this point here, you simply define the difference between where you are standing and the previous point, which is f of x minus h. So this is by definition. And we also know that shift of f of x is given by f of x plus h. What that one tells you is that the shift operator takes you to the next step. So you are at this f of x, then it is the same as going to the next step at x plus 1, whose value will be f of x plus h, whose value will be f of x plus h. Now, also we know that the forward operator of f of x is the difference between the next step ahead, which is f of x plus h, minus where you are standing at f of x. So this difference is starting from the next step back to where you are standing. Now, with these definitions, then we can say that the backward of f of x, whose definition is f of x minus f of x minus h, can be interpreted as okay, so with this definition, then we can define the backward of so just say since backward of f of x is given by this formula, then backward of f x plus h will be given by f of x plus h minus f of x. This by definition, still from this definition, that if you are at x plus h, then you'll be standing at f of x plus h, and then you subtract the previous step. So this on this diagram here. So at this point, you'll be defining the value at this point minus the previous point, so which is f of x. And you see this on its own agrees with the definition of forward of f of x. So we can say this is the same as the forward of f of x. Similarly, if I define backward of f of x plus 2h, then I'll have f of x plus 2h minus f of x plus h, which is the same as the forward of f of x plus h. Because remember, this part can be written as x plus h. This can be written as f of x plus h, and then plus h minus f of x plus h. These are the role of x in this definition is taken by x plus h. So that's why we have this. Similarly, if we define backward of f of x plus 3h will be f of x plus 3h minus f of x plus 2h, which is the same as forward of f of x plus 2h. Now this pattern will continue up to the point I define the backward of f of x plus nh. I'll get f of x plus nh minus f of x minus plus n minus 1 h, which defines the forward of f of x plus n minus 1 h. So similarly, we can define second forward differences, second backward difference of the function f of x plus 2h is the same as forward of backward of f of x plus 2h. So which is the same thing as backward of, by definition of this one, we have forward of f of x plus h. So which can be written as forward of f of x And then do the same thing as writing forward squared of f of x. Remember the reason as why you are writing this one here at this point here, just so that things are clear. At this point, when we have backward and then forward of f of x plus h is the same thing as writing forward of backward of f of x plus h. So it's the same as forward of, now backward of f of x plus h is given by forward of f of x. So that's why we are moving from this step to this step. So you simply commute these two operators. So this is the same as, so these two operators commute. So that's why we have from this point to this point here. And so in general, if you raise this to power n of x plus nh, then you get the forward power n raised power f multiplied by f of x. Now, okay. So let's just write this one properly. Backward power n f of x plus nh so this is the result in general. Now, we also know that by definition, backward of f of x is given by f of x minus f of x minus h. And then we also know the result that shift of f of x is given by f of x plus h. So if I say second shift of f of x, then I'll be applying shift to the first shift of f of x, which is the same as shift of f of x plus h. Now this one, next step will be f of x plus 2h. And then third shift of f of x is you apply shift to the second shift of the function f of x, which is the same thing as applying shift to the value of the second shift is f of x plus 2h. And so the next step from x plus 2h is x plus 3h. And so this pattern keeps on up to, if you say e raised power n f of x, the result is f of x plus nh for any real number n. So when I take n to be a negative value, then I'll have e power negative n of f of x is f of x minus n h. So with this result, it means that when n is 1, if I pick this, then e power 1 f of x is the same as, I'm just saying that if I pick, this is the general one for any given n. So when you pick n to be 1, then this is given by f of x 1 times h is h. And then when I pick n to be negative 1, then I'll have e raised power negative 1 of f of x will be f of x minus h. So that if I have backward of f of x given by f of x minus f of x minus h, then I'm allowed to replace f of x minus h by e raised power minus 1 f of x. And so the right-hand side of this equation, every term has an f of x. So we can write 1 minus e raised power minus 1, and then f of x. And for this equality to make sense, then this implies that backward must be the same as 1 minus e raised power negative 1, or the same thing as saying e raised power negative 1 is 1 minus the backward difference operator. Or we can write this one as 1 over e is 1 minus backward. So, which implies that e reciprocal will be given by 1 over 1 minus backward. Or you can as well say that the backward operator from this point will be given by 1 minus e raised power negative 1, which is the same thing as writing 1 minus 1 over e, which is e minus 1 is given by backward. So all these are different expressions of the relationship between the backward difference operator and the shift operator, or either this or this all these are the relationships. So in the next session, we'll give more identities involving these operators. Thank you.